Good morning, students. So today we'll start exercise 3.2. We have left it over in exercise 3.1. So today we'll be starting exercise 3.2. Okay. So before we start exercise 3.2, we need to know two definitions. That is, what is prime numbers and what is prime number and what do you mean by composite numbers? Okay, composite numbers. So in the first test, I have told you to learn few definitions like prime numbers, composite numbers, even and odd numbers. So what do you mean by prime numbers? So we can say that prime numbers are numbers having exactly two factors. Okay, having exactly two factors. And what do you mean by composite number? Composite number means numbers having more than two factors. Okay, numbers having more than two factors. What will you say example of prime numbers? Example of these prime numbers. Example of prime number, you can say like 1, 2, 3, 5, 7 and 11, like this. Okay, because see, it will have only two factors, 1 and the number itself. That means this 1 will have only 1 as its factor and 2 will have 1 and only 2 as its factor. What about 3? It will only be divisible by 1 and 3 itself. So you can say that the number which are divisible by 1 and the number itself. See, every number is always divisible by 1. But what other than 1? This number 5 is only divisible by itself. So no other numbers will divide 5. So you can say in that way, you can say that all these numbers are prime numbers. Okay, so like 1 and 7, this also 11 will also have only 1 and 11. You can see that 1 and the number itself are known as prime numbers. Okay, what do you mean by composite numbers? We have said that numbers having more than two factors. So what will be the example? Suppose we can say 4, 6, 8, 10. See, they will have more than two factors. Like this will have 1, 2, 4. What about 6? 1, 2, 3, 6. That means these numbers are dividing 6. Okay, these numbers are dividing 4. 1, 4 are 4, 2, 2 are 4, 4, 1 is 4. That is why these are the factors of 4. See, 6 also, 1, 2, 3 and 6. That means 2, 2, 3 are 6, 3, 2 are 6, 6, 1 is 6 and 1 is 1, 6 is 6. So in that way we can say that all these numbers are factors of 4 and 6. What about 8? You will say that 1, 2, 4 and 8. These numbers will divide 8. What about 10? 1, 2, 5 and 10. See, they are having more than 2, isn't it? They are having more than two factors. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So in this way we can say that they are the factors of this number and they are called as composite numbers. Okay, so these are the definitions for this exercise. Now we'll start with exercise 3.2. okay, so let's start with exercise 3.2. So see the first question in your textbook, page number 53. Okay, so if you see the first question, what is the sum of any two odd numbers and even numbers? So we have to see, first we'll do the sub number A, which is saying odd numbers, sum of odd numbers. Take any two odd numbers. So what do you mean by odd numbers? The number which is not divisible by 2. So we can take any two odd numbers. Suppose we take 1 and 3. Now the question is saying, what is the sum? Sum means we have to add them. So 1 plus 3, what will it give you? 4. So you can say that if we are adding two odd numbers, we are getting what? 4 is an even number. So you can say that adding two odd numbers is giving you even number. Okay, this is for sum number A. What about B? Even numbers. Take any two even numbers. Suppose we take 2 and 4. These two are even number. Now we have to add them, isn't it? The question is saying what is the sum. So 2 plus 4, what will it give you? 2 plus 4 will give you 6. That means even plus even is giving you even number only. Okay, this is for sub number A. Sub number 2, it is saying state whether the following statements are true or false. Okay, first you try it yourself, okay, because here we don't have much time to explain. I don't have much time to explain to you, but if you have problem, then later I will explain you again. Okay, so we'll move to number 3. The answers you can find in the back of your textbook. Okay, true and false. If you later I will explain you if needed, otherwise it's not needed. If you understand what is even number, what is odd number, you can do it yourself. Okay, so next we'll start with number 3. Next is number 3. So what is number 3 saying? Number 3 saying the numbers 13 and 31 are 13 and 31 is given. Okay, and it is saying both are prime numbers, so we have to take prime numbers. And what do you mean by prime number? First, the number divisible by 1 and itself are called prime numbers. So both these numbers have same digit 1 and 3. The question is saying both these numbers have same digit 1 and 3. If you see 13, it is having 1 and 3, and if you see 31, you are having 3 and 1. So now it is saying find such pairs of prime numbers up to 100. So for us, we have to think prime numbers up to 100. Okay, and the numbers should be same. Suppose we are taking 16, then we have to take as other number as 61. The number 1 and 6 is present, so 1 and 6 should be present in the other number as well. But here 16 is not a prime number, so we'll not take this one. Okay, so let's see what can we say. So if you take 17, so you can see that 17 is a prime number because it is divisible by 1 and 17 only. No other number can divide this 17. And if you take the other number as 71, so is it correct? So are we getting a pair? Obviously, because 1 and 7 is present here, and also in 71 we are getting 1 and 7. So what others can you think? What other number can you think? So if you think in that way, if you think in your mind, if you reach 18, 19, 20, 21 like that, if you go in your mind, you will get 37. Okay, so 37 is only divisible by 1 and itself. That means 1 and 37. What will be the other number? 73, because we have to check whether 3 and 7 is present here also, and this would be a prime number. So obviously this is also correct. What other number can we think? If we think 79, obviously this is also a prime number because it is divisible by 1 and itself. So what will be the its other pair? 97. Okay, so if you think 98, 99, this is not possible. So only up to before 100 we are getting 97. So up to here only this would be your answer. Okay, we have to think up to 100. So 98, 99 and 100, this is not possible because we have to, question is saying it should be a prime number as well. So the pairs are 17 and 71, 37 and 73, 79 and 97. Okay, next let's move to next question, which is question number 4. What it's saying, if you read the question, write down separately the prime and composite numbers less than 20. So we have to write prime number as well as composite number up to 20. So as we already know, that is why I have made you to know the definition, because here we are needing it now. See, we have to write prime number up to 20 and composite number also up to 20. So we have known that prime number is the one which is divisible by itself and 1. Okay, so prime number we can think 2 up, so we have to write up to 20. How do we know this is prime number? Because it is only divisible by 1 and itself. So this is a prime number. 2 is a prime number. Okay, so next 2, what else can you think? 3, 5, 7, 11, 13, 17 and 19. Okay, you think in your mind as well whether they are divisible by 1 and itself only or not. So I think up less than 20, only this much for prime number. What about composite number? It should have more than two factors. So if you think 4, how many factors it is having? 1, 2, 4. So this is having 3 factors. So in that way you have to think for composite number less than 20. Okay, so 4, 6, 8, 9, 10, 12, 14, 15, 16, 18. So if you write the factors for all these, no need to write, but if you write, then you will find that it is having more than 2 factors. Okay, that is why they are having That is why they are called composite numbers. Okay, so if you note down, you can note down, this is the answer for number 4. Okay, number 5. Let's see what is the next question saying. Number 5. Okay, what is the greatest prime number between 1 and 10? So what will you say? What will be your answer for what is the greatest prime number between 1 and 10? Obviously 7 will be the greatest prime number, because no, it is only divisible by 1 and itself. Itself means 7. So this is the greatest prime number between 1 to 10. Suppose the question asks you, this is the greatest. Okay, just in case, if the question asks you what is the smallest prime number, then what will be your answer between 1 to 10? So 2 will be the answer. Okay, smallest will be, the question is not asking, but I am giving you because it may be important. 2 is the smallest prime number between 1 to 10, and the factors are 1 and 2, isn't it? This is the smallest. Okay, so let's go to number 6. Express the following as the sum of two odd primes. So a number is given, 44 is given, okay, in the question. So what we have to do, we have to express the following as the sum of two odd primes. We have to take a prime number which should also be a odd and add them up. Suppose you have to take prime numbers, isn't it, which should also be odd. So if you take 41, is this a prime number? Yes. And what about 3? 3 is also a prime number. So when you add this up, 41 plus 3, you'll get 44. Okay, in that way, what can you you can also think for others, like what else can you make 44? If you do 37 plus 7, will you get 44? Yes, because this is from both are prime numbers and we have to add them up to get the required digit 44. Okay, this is other. Can you get one more? So if you think 31 plus 13, both these are prime numbers as well as odd. So you can, if you add them, you'll get 44. So the answer for them is 41 plus 3, 37 plus 7, and 31 plus 13. Okay, I'll do one more for you. I think it's more than enough to make you understand. Let's try 36. So first you have to take odd number. So if you take 31, so this is obviously a prime number as well as odd. So 31 plus 5 will give you 36. Okay, this is one. 29 plus 7 will be the other one. Okay, because it is giving you 36, because both are prime numbers and also odd. What is the last one? What will you get? If you take 20, what will you take? Suppose let's take 13 in this side. So what will you add to get 3? 23. 23 plus 13, both are prime number as well as odd, and you are getting 36. Okay, in this way you have to think in your mind what will be the two prime numbers I should take, so that if I add them I will get the required digit. Okay, like we have to get 36, and we have to, question is saying you have to take two odd primes. The number should be odd number as well as prime. Okay, so you already know the definitions. Odd numbers are what? With the number which is not divisible by 2, and prime number, it should have only two factors, 1 and it and the number itself. Okay, so we have finished 6. Let's continue. What is number 7 saying in your question? What is number 7 saying? It is saying give 3 pairs of prime numbers whose difference is 2. What is the question saying? It is saying give 3 pairs. We have to make 3 pairs. Okay, so that if we subtract them, difference means subtract, so if we subtract them, we should get 2 as your answer. Okay, so we have to take 3. So let's think in our mind. Give 3 pairs of prime numbers. So if you take 3 and 5, is this prime number 3 and 5? Yes, why not? Because they are having only 1 and the number itself as their factor. So if we subtract them, are we getting 2? Is our difference 2? Yes, so one pair is 5 and 3. Next, let's think what will be the other one. If you take 5 and 7, are both these prime numbers? Yes. So you can say that 7 minus 5 will give you 2. That is what we are searching. The question is saying the difference should be 2. That means if we subtract the selected prime numbers, our difference should be 2. Okay. So that means this is our prime numbers we select, and now we are subtracting them, and we are getting 2 as our answer. So what one more pair can you think in your mind? Can you do it yourself? Okay, I'll help you here. So if you take 11 and 13, so if you subtract them, will you get 2 as your answer? 13 minus 11 will give you 2. So this is our required answer. Okay, so this is, in this way you have to think. And also you can take 15, 13, okay, the pairs 15 and 13, 17 and 15, 21 and 19, like that. Okay, so we need to select only 3 pairs, so I have selected these numbers. Others also you can try yourself. Okay, let's go to number 8. Let's go to number 8. What is it saying? Which one of the following numbers are prime? So which one of the following number is prime? Is 23 a prime number? Yes, because it is having 23 is a prime number. 1 and 23 are its factor. 23 is correct. What about 51? 51 is not a prime because it is having more than 2 factors. Okay. What about 37? 37 is a prime because it is having only 2 factors, 1 and 37. Why this is not prime? Because the factors are 1, 3, okay, like that. It is having more than 2 factors. That is why this is not prime. 51 is not prime. So what about others? The last one is 26. Is this a prime number? Not prime, because in 26 already you can see that the last digit is a even number, so it will never be a prime. Okay, not prime. Okay, what is number 9 saying? Your question number 9. If you see question number 9, write 7 consecutive composite numbers less than 100 so that there is no prime number between them. Okay, you have to select 7 consecutive. Consecutive means like we have to select a number in such a way that there should be no gap between them. Suppose we are taking numbers like 1, 2, 3, 4, 5, 6. Okay, all these are consecutive numbers because it is moving in a what? Like a train. There is no gap between them. Suppose if we take 1, 3, 5, then we can say that these numbers are not consecutive because there is a gap between them. Missing number are there in between them. So these are not consecutive number, but these are consecutive numbers. Okay, so we have to write 7 consecutive composite numbers. Okay, so there should be no prime number between them. So what numbers can we take? Suppose if we take 90, 91, 92, 93, 94, 95 and 96. Okay, so you can see that these all are composite numbers. Okay, and they are also less than 100, and in between them there is no prime numbers. Okay, so this is your answer for number 9. Okay, there is no can you see, no one is a prime number. All will be having factors more than 2. So these are all composite numbers. What is number 10 saying? Express each of the following numbers as the sum of 3 odd primes. Okay, that means we have to take 3 odd numbers. 3 odd numbers, and it should be a prime, and we should add them up. Okay, we have to make a sum. So for 21, how can we make 3 odd numbers and it should be also a prime, and if we add them we should get 21. Suppose if you take 3, this is the odd number, isn't it, as well as prime. 3 plus 5 plus 13 will give you 21. So you can see that it is having sum of 3 odd primes. The question is saying we have to make 3 odd primes. So this 1, 2, 3, we have taken 3 numbers, and when we add them we are getting 21. This A. Number B is 31. So what will be this for 31? If you take again 3 plus 5 plus 23, what will you get? You will get 31. Okay, in this way you have to think. So number C is 53. So how can you add them? 3, if you take 3 plus 7 plus what? In your mind you think 43. So if you add them you will get 53. Can you take one more for this? in your mind, because one is, you can take others also, okay? This is just in my mind. Like you have to think in such a way that whatever number you take, it should be a odd number as well as prime, and it should be 3 digits. When you add them, they are 3, isn't it? 1 2 3. You should take 3 numbers. When you take 3 numbers and add them, you should get the required digit. So let me think for 53 one more, okay? So if you take 7 plus 17 plus 19, and if you add them, you are getting 53. So in this way we'll do number 10, okay? Let's see 11. We'll finish this exercise 11. After 11, the last is filling the blanks. So what is 11 saying? Write 5 pairs of prime numbers less than 20, okay? Less than 20 whose sum is divisible by 5. So you have to think in such a way, you have to make 5 pairs again. 5 pairs. 1 2 3 4 5. The question is saying 5 pairs. Write 5 pairs of prime numbers less than 20. You have to also select prime numbers which is less than 20 whose sum is divisible by 5, okay? So whatever we take, it should be divisible by 5. So if you take prime numbers 2 and 3, so when you add them, what will you get? 2 plus 3 is equals to 5. So number 5 is divisible by 5, isn't it? So this is our one option, one correct answer. What will be the next pair? The next pair you can take as 3 and 7. Now add them, what will you get? 3 plus 7 will give you 10. So is this divisible by 10? 10 is divisible by 5. Yes, because 5 2 are 10. So this is also a correct pair. What will be the next pair? If you take 2 and 13. So if you take 2 plus 13, it will give you 15. That means 15 should be divisible by 5. Is it divisible? Yes, 5 3 are 15. So this is also a correct pair. 2 plus 13. Next, what do you get? 3 and 17. You have to take prime numbers, okay? Less than 20. So first we are taking this. 3 plus 17 will give you 20. So 20 is also divisible by 5. 5 4 are 20. So this is a correct pair. And the last one, can you think yourself? Can you think yourself? Easy. You just take 5 and 15. 5 plus 15 will give you 20. So this is also a 20 is divisible by 5. 5 4 are 20. So this is also a correct pair, 5 and 15, okay? So we have now got 5 pairs. So this is the answer: 2 3 3 7 2 13 3 17 5 15. Okay, easy, isn't it? Now let's, and also when you select, it should be a prime number, okay? If you see all these numbers 5 and 15, 3 and 17, it is only divisible by itself and 1, okay? So in this way you have to think. Number 12, okay, I'll just write the answer, okay, because this is filling the blanks. For number A, the answer is prime number. Number B, the answer is composite number. Number C, prime and composite. Prime and composite is the answer. Number D is 2. I have already told you the smallest prime number is 2, isn't it? And the smallest composite number is 4, because it will give you more than 2 factors, and it is, what are the factors of 4? 1 2 and 4. So that is why it is not a prime number but a composite number, because it is having more than 2 factors. Number F, lastly, what is the answer? 2 will be the answer, okay? So in this way we finish exercise 3.2. So if you can see, I think you can see. So let's end here, okay? We will try to finish exercise 3.3 in the next video. Thank you.